Hey everyone, and welcome back. We're diving into the world of LLMs today, large language models.
Yeah, LMs.
Yeah, they're everywhere these days, and for good reason.
Yeah,
They're really changing how we interact with tech. I mean, think about it. Search engines are everything,
totally.
and we'll be using foundations of large language models as our guide for this one. Should be interesting.
It really is a fantastic resource uh, for getting into how all this works. I mean, these LLMs, they seem kind of magical,
Yeah,
but there's actually a lot of science and engineering, behind them.
right. It's not magic, but sometimes it really does feel that way.
Yeah.
I mean, these models can write like humans, translate languages. They can even write creatively.
Mm-hmm.
It's pretty mind-boggling. But I'm really curious about how they actually learn,
Yeah,
how they do all that. And I think a lot of our listeners are too.
absolutely. So, it all starts with pre-training. Like, we need a foundation for a house.
Right.
LMs need pre-training to get that basic understanding of language.
Okay, that makes sense. But what does that pre-training actually look like? I mean, we can't exactly give them flashcards, can we?
Well, not exactly. Imagine, teaching a dog like basic commands. You start with sit, stay,
Right.
simple stuff before you move on to the more complex tricks. Pre-training in LLM is similar.
Okay.
It's feeding them a ton of text data
Yeah.
and then training them to predict the next word in a sequence.
So it's all about prediction, kind of like a big fill-in-the-blanks game.
Exactly. And this game, it helps them develop a really deep understanding of language.
Uh-huh.
Like, take masked language modeling, MLM. You show the model a sentence with some words hidden,
Okay.
and it has to guess those missing words based on what's around them.
Got it.
It's just like a puzzle.
Can you walk me through an example?
Sure, so imagine the puppies are mask outside mask house.
Okay.
The model's got to predict those blanks. It might say playing and the
Yeah.
based on those other words. And doing this a ton with millions of sentences, the model learns how words relate to each other, grammar, syntax, all that.
Wow. So they're learning by figuring out the most likely word based on what's around it.
Yeah.
It's like they're breaking some kind of code.
Mm-hmm.
But you mentioned another game they play.
Yeah. There's also next sentence prediction, or NSP.
Yes.
This one, you give the model two sentences, and it has to tell if they make sense together. So, like, does I need an umbrella make sense after it is raining?
Yeah, definitely. So these simple exercises are actually teaching the model the flow of ideas, how sentences connect.
Right.
And that must be important for like writing good paragraphs or even summarizing longer stuff.
Yeah, exactly. These pre-training tasks are like the foundation for understanding how language works, and then they build on that for all the more complex stuff.
So we've got these models learning the basics, MLM, NSP.
Right.
But what about when we want them to do something specific, like translate or write creatively?
Yeah.
Do we just tell them to do it, or is there more?
Well, think about it. You wouldn't expect someone to just write a sonnet just because they know the alphabet, right?
Yeah.
They need training guidance.
Right.
And that's where fine-tuning comes in. Taking a pre-trained model and then training it on specific tasks.
So like specialized training for a specific job?
Exactly. Let's say we want short stories. We'd fine-tune it on short stories and give it prompts like, write a story about a detective and a missing cat.
I like where this is going. What did it write?
Well, after fine-tuning, maybe something like Detective Miller, a man of routine and logic, found himself drawn to the case of Whiskers, a ginger tabby vanished from a locked apartment.
Whoa.
As he delved deeper, the clues pointed to a world beyond milk and catnip, a world of feline intrigue he never knew existed.
Wow, that's pretty good. It took a simple prompt and made a whole story.
Yeah.
But how do researchers make sure all this creative potential is used responsibly? I mean, we don't want LLMs generating bad stuff.
You're right. That's a really crucial point. And it leads us to this idea of alignment, basically making sure LLMs behave ethically in line with human values. And one of the main techniques for this is reinforcement learning from human feedback, or RLHF.
RLHF, I remember us talking about that. It's like training a dog with treats, right?
Yeah. You reward the model when it does good, discourage it when it doesn't, shaping behavior through rewards and penalties.
So we're teaching them to be good digital citizens.
You could say that. It's teaching them to not just understand our instructions, but to act in a way that aligns with our values and preferences.
This all makes sense, but this whole thing seems massive.
Yeah.
Tons of data, complex algorithms.
Yeah.
How do they actually train these models at such a large scale?
That's a great question, and it brings us to the whole challenge of scaling up.
Okay.
Training LLMs takes a ton of computational power, and you need innovative techniques to handle all that data.
Yeah.
It's kind of like building a rocket ship.
Okay.
You need the right materials, the right design, and a lot of power to get it off the ground.
I think I'm already feeling a little overwhelmed. I have so many more questions about how all this works in practice, but maybe we should take a breath here.
Sounds good.
Let our listeners digest this.
Yeah, we've covered a lot, from pre-training to fine-tuning and alignment.
And for you, dear listener, the key takeaway is this. LLMs are incredible tools. They could change so much. Generating text, translating, creative writing, so much more.
Yeah.
But it's still early days, and there's a lot of work being done to make sure they're used responsibly and ethically.
Exactly. We'll be back soon to go even deeper into this world,
Yes, we will.
looking at how researchers are tackling those scaling challenges and pushing the limits of what LLMs can do.
Stay tuned. We'll be right back.
Welcome back, everyone. We're going to keep diving deeper into LLMs now.
Yeah, we're going to explore how these models handle very long pieces of text.
Okay.
Long sequences, which are super important for real-world stuff. All right, we talked about this a little bit before, but I want to know more about what makes this long sequence modeling so tough for LLMs. I mean, if they can analyze millions of words during pre-training, why is a longer text a big deal?
It's a good question. It's kind of like juggling.
Okay.
You can juggle a few balls, but at some point it just gets too much, right?
Yeah.
Same with long sequences.
So what makes it so hard? Is it just about the computing power?
Well, that's part of it, but the real problem is in how standard transformers work, specifically something called self-attention.
Okay, self-attention. Remind me how that works and why it becomes a problem with longer texts.
Sure. Imagine reading a sentence.
Okay.
Self-attention lets the model look at how every single word in that sentence relates to each other to understand the meaning. But the longer the text gets, the more of these relationships there are.
So if the text is twice as long, the model has 4 times as much work to do.
Yeah, exactly. And with really long sequences, it just needs way too much power. It's like running a marathon with a ton of bricks.
Okay, yeah, that makes sense. So how are they tackling this? Just throwing more computers at it?
Well, faster computers help, but that's not the whole solution.
Right.
Researchers are coming up with really smart techniques to make LLMs better at these long sequences, like teaching them to juggle with more finesse.
Okay, I like that. What are some of these techniques?
One thing is sparse attention.
Okay.
Instead of looking at every single word in a long sequence, it focuses on the most important parts, like skimming a book to get the main idea.
So it's about prioritizing, being selective.
Exactly. And there are a few ways to do this. Sliding window attention, for example.
Uh-huh.
That lets the model process little chunks of text at a time, like moving a magnifying glass over a page.
Oh, I like that. That makes sense.
Mhm.
But what about when you need to remember something from way earlier in the text? Like, what if the key to the whole chapter is in one sentence on the first page?
Right. Well, that's where memory-based methods come in.
Okay.
They give the model a memory bank,
Yeah.
so it can store and retrieve information from anywhere in the text.
So like giving it a notepad to write down the important stuff as it goes.
Exactly. One approach is retrieval augmented generation, or ARG,
Mm-hmm.
where the model can basically look up relevant info like we do online.
Right.
This lets it handle those longer sequences without losing track of the important context.
I see. That's really cool. But what about word order? How do they keep track of that in a really long sequence? That seems pretty important for getting the meaning.
You're right, it is, and that's where positional embeddings come in. They're like tags
Okay.
that tell the model where each word is in the sequence, like giving each word a unique address.
So like a GPS coordinate for each word.
Exactly. And for those super long sequences, researchers have even fancier techniques that can handle lengths way longer than what they saw during pre-training. That way the model doesn't get lost and can still keep track of the order.
Okay, so all these different approaches are working together to help LLMs tackle longer and longer sequences. But why should we care about this? What does it mean for us?
Good question. Long sequence modeling opens up a ton of possibilities.
What?
Imagine an LLM that can analyze thousands of research papers to find new treatments for a disease, or a system that can summarize complicated legal documents in plain English.
Wow, so it could help us make sense of all the information out there.
Yeah, and that's just the beginning.
It sounds like long sequence modeling is pushing the limits of what LLMs can do.
It really is.
Are there any downsides to this, though? Any challenges that researchers still need to figure out?
Of course, there are always challenges. As these models get more powerful, we have to be extra careful about making sure they're aligned with human values and don't cause any harm.
Right. Just because they can process a lot of information doesn't mean they always understand it or use it responsibly.
Mhm.
So how do researchers make sure these models are aligned with human values and don't go off track?
That's actually something we'll be discussing in more detail in our next segment, where we'll dive into AI alignment. But for now, I think the key takeaway is that long sequence modeling has huge potential,
Yeah.
and it's up to us to make sure it's used wisely and ethically.
Great point. So let's recap what we covered here.
We talked about the challenges of long sequences and how researchers are using sparse attention, memory-based methods, and positional embeddings to overcome them.
Yes.
We also discussed some of the exciting applications and the importance of using this technology responsibly.
Right. And for our listeners, the key takeaway is that LLMs are getting much better at handling the complexities of human language. They're not just generating text anymore. They're starting to understand and interact with it in a really meaningful way.
Exactly.
And in our final segment, we'll be tackling how we can guide these powerful tools towards a future that benefits everyone. Stay tuned. We're back for the final part of our deep dive into LLMs. We've talked about how they learn, how they handle long sequences of text, and now we're getting to something that's been on my mind this whole time.
Yeah, we're going to talk about AI alignment. How do we make sure these really powerful models are used for good? It's a question that's getting a lot of attention as LLMs become more and more capable.
Right. It's one thing to have an AI that can write poems or translate,
Mm.
but it's different when we think about what could happen if they're not aligned with human values.
Exactly. Like imagine an LLM that can write really persuasive stuff. It could be used for marketing or speeches, but it could also be used to spread misinformation or manipulate people.
That's a little scary, yeah.
Yeah.
So how do we make sure they're used for good? We talked a bit about reinforcement learning from human feedback, RLHF.
Yeah, RLHF is a big part of aligning LLMs with what humans want. It's about teaching these models to not only understand our instructions, but to create outputs that we see as good, ethical, aligned with our values.
You compared it to training a dog with treats, rewarding good behavior and discouraging bad.
Hmm.
But how does that work with AI? They don't exactly eat treats.
It's a good analogy. Instead of treats, we use rewards and penalties to guide the LLM as it learns. We might show it different responses to a prompt and have humans rate them based on how much they align with what we prefer. Over time, the model learns to make outputs that get higher ratings, which means outputs that are more likely to be aligned with human values.
So we're showing them what we consider good and bad, and they learn from that.
Exactly, like teaching a child right from wrong. We show them examples, explain why the rules are there, help them understand.
That makes sense.
Yeah.
But this whole thing seems complicated. How do researchers actually do this with the rewards and penalties?
There are lots of approaches. It's a really interesting area of research. One common one is using a reward model.
Okay.
It's basically a separate AI that's trained to judge how well an LLM's output aligns with human preferences.
So it's like having judges score the responses.
That's a great way to put it. And that reward model also learns from human feedback. We might give it responses and ask humans to rank them from best to worst. So over time, it gets better at predicting what humans will like, and it uses that to guide the LLM.
This is really cool. But where does all that human feedback come from? Are there people just evaluating LLM outputs all day long?
That's a good question, and it shows why human-centered AI development is so important. There are different ways to get that feedback, from crowdsourcing to experts. The key is to make sure it's diverse, representative, and high quality.
So you need enough data to train the models, but it also has to reflect a wide range of views and values.
Exactly. It's a challenge, and researchers are always looking for ways to improve how we gather feedback for AI alignment.
I think some people might be a little worried about all this. Are we relying too much on AI to solve ethical problems that humans have been struggling with forever?
That's a fair point, and we have to be careful and humble about AI. Alignment isn't about replacing human judgment. It's about creating tools that can help us make better decisions.
So it's about helping us be more ethical, not handing it all over to machines.
Exactly. It's a collaboration. We provide the values, the guidance, and AI helps us apply those consistently and on a larger scale. It's about using AI to create a better future for everyone.
That makes sense. And it brings us back to something we've talked about. What does the success of LLMs tell us about language and intelligence?
That's a big question. Maybe the most important thing is that language isn't just for communication. It reflects our thoughts, values, how we see the world.
And by teaching machines to use language, we're not just building tools, we're learning more about what makes us human.
It's a journey of discovery for both AI and for us. As we see what machines can do, we also learn about the incredible complexity of our own minds.
This has been an incredible journey. Thanks for taking us on this deep dive into LLMs.
It was my pleasure. And to our listeners, keep exploring this field. It's changing so fast. LLMs could change so much about our lives, and it's up to all of us to make sure they're used for good.
That's a great point to end on. As we develop more and more sophisticated AI, we need to do it responsibly and ethically, always remembering what makes us human. Thanks for joining us on the deep dive.